Hello again, everyone. So our third and final assignment in the unit is to learn how to calculate arc length in any circle, which is the radian concept, by the way. So radians is the length of the unit circle or any circle that's swept out by an angle measure. I think in trying to keep things the least confused in dealing with this massive amount of information, I'm going to use just the radian formula. So this page is in your notes. This is the radian formula. In other words, I'm going to convert all angles that are given in degrees to radians and then use this, which is a very simple formula, r times theta. R is the radius. The concept of arc length in any circle is simply a fraction of the circumference. And so it doesn't even have to be an angular fraction. You'll see that in the two problems on the practice quiz, that you're just looking at trying to figure out what that fraction of the circle that swept out is, and then multiplying by 2 pi r, so that'll be a little different approach. Anyway, I think the r times theta, so this simplifies, the 2 pi's drop out into r times theta. Theta given in radians is so simple to use. We can do 4 problems in less than a minute on the front of our notes. On the back, we're working backwards, and I still think working in radians is the best thing, and we'll cross multiply to solve for r, or to solve for theta. All right, so here's how this is going to look. Again, remember, we are going to keep everything in terms of radians. So you see that number 1 is given in terms of radians. So r times theta is the formula. So we're doing 5 times 2 pi over 3. How simple is that? And that is 10 pi over 3 centimeters. Pretty simple work. I would say, just for the sake of how answers are posed, that it is okay to leave your work in terms of pi, unless the problem asked you to convert it to a decimal. So theta equals 180. That is pi radians. Yet I'm going to use the r times theta formula because it's so simple. So 2 times pi, that's it, inches. It just is very simple. 120 degrees. What is that? Remember, how do you convert from degrees to radians? You multiply by pi over 180. So this will be 2 pi over 3 radians. Again, reduce the 120 over 180. Think of the pi like a variable. Leave that alone and then just put it back in the answer. So r times theta, 3 times 2 pi over 3. Well, that's going to be 2 pi again because the 3's drop out, centimeters. Number 4, so we have 3 pi over 2, that's already in radians, so very nice, is 5 times 3 pi over 2. Just do the 5 times 3 and you got it. 15 pi over 2 centimeters. Easy enough. Keep it in terms of radians, and life is pretty simple. All right, so on the back, we're going to move backwards, and we're going to have a little cross product to do. So the arc length is given to you. That's 9 pi. We don't know r, but we know that theta is 3 pi over 4. Okay, so what I'm going to tell you is that the pi's drop out of this. And you can essentially just drop them like that. And then I want you to think of a cross product going on where this side is a 1 if you want. 9 over 1. I'll rewrite this so it makes a little bit of sense. And then on this side, it's 3r over 4. So eliminate the pi's, kind of condense like this. So 3r equals 36. So here's your cross product. Remember, only do a cross product if you have one single fraction equals another. It has to be one single fraction equals another. 12 inches. Okay, number 6. Notice the 240 degrees. So we want to convert that into radians to make life a little easier. And that is 4 pi over 3. Okay, so same idea here, r times theta. So 40 pi over 3 equals r times 4 pi over 3. Well, you might be able to look at that and say r is 10, because 10 times 4 is 40. And if that's what you want to do it. Other than that, you would have to cancel the pi's out. You can multiply by 3 on both sides. You'd have 4r equals 40. If you wanted to look at it that way, and then r would be 10. I'll write that down just so we're doing a little work. So a circle has an arc length of 2 pi with a radius of 4. Okay, what is the central angle in radians? So starting the same way here. So arc length is 2 pi and the radius is 4. Now we're finding the angle. So it doesn't really matter. You're just dividing out and solving for the others. So divide by 4 on both sides. And that reduces to pi over 2 radians. Okay, circle has an arc length of 20 pi over 3 and a radius of 4. What is the central angle in degrees? So you might have a little converting to do here at the end, which is all right. So you want to divide by 4 on both sides. That's going to create, think of multiplying by 1/4, a 20 pi over 12. And then how do you convert that to degrees? Remember that you need to multiply by 180 over pi. So always think about eliminating the pi to go to degrees. So that's how you know, if I multiply by pi over 180 or 180 over pi, you want to eliminate the pi out of there. And then just do the 20 times 180 over 12. And this will be 300 degrees. Okay, so there's your arc length assignment. Pretty simple work. Keep everything in radians because that is such a simple formula to use. You are referring to this page in your notes. There is a degree formula, but it's very convoluted to use it. But anyway, I think that the r times theta one is the simplest one to use.